Number 33. Use the standard free energy of formation data in Appendix G to determine the free energy change for each of the following reactions, which are run under standard state conditions at 25 degrees Celsius, and then identify as either spontaneous or non-spontaneous at these conditions. Okay, so we have our first reaction, which is MnO2 solid, which will yield Mn solid plus O2 gas. Now, we have to find out what that free energy change is, right? When they're talking about a free energy change, any change is a delta sign. So we're looking for a delta. And free energy is always talking about Gibbs free energy, which is delta G. Now, delta G will be able to tell us whether we're spontaneous if we're basically producing, the products without any external amount of energy needed, or non-spontaneous if we do need a little push, a little external energy to get us there. That's going to come down to whether our delta G is going to be a negative or a positive value. Negative delta Gs, or delta Gs that are less than 0, the reaction is spontaneous. But if your delta G is over 0, which is the same thing as just saying any positive value, that reaction is non-spontaneous. Now, I did go in the back of the textbook to find out what the delta G formation values are for each individual component. So any elemental substances always have a delta G of 0. So like a standard state, elemental substance, manganese solid, O2 gas, zeros. But for compounds, chances are they're going to have an actual value. And for MnO2, it's a negative 465.1 kilojoules per mole. Let's find out that delta G. Now, since we're using standard conditions, 25 degrees Celsius appendix values, we're solving for a delta G notch. Anytime that you see that notch, that just means that you're under standard state conditions. Formula for this one is here. It's basically the same as any delta H or a delta S value, right? Delta G for the whole reaction, Rxn is reaction, is equal to, and maybe I'll just pull this a little bit down, is always equal to the sum, that's this, right? The sum of all your delta G products, sum just means addition, right? Minus the sum of all your reactants. So essentially it's products minus reactants. Now, are these values going to change? Well, it just depends on the coefficient of the balanced equation. But in this one, there is no values in front of each substance. MnO2, Mn, and O2, you all have one of these. Which means that these values would all be times by 1. But if you times it by 1, that just means that it's the same number. But I'm just showing you just to kind of give you a structure as to, what happens if there was 2 Mns. You would times that by 2. Now we have to sum them up. Keep in mind, this is Mn solid plus O2 gas. So it's this value plus this value. But 0 plus 0 is 0. So the total on the right side is 0, and the total on the left side would be the negative 465.1. Now, let's just plug it in and solve. So delta G for the whole reaction equals your products, which is 0, minus your reactants, which is a negative 465.1. And in this case, we could use the calculator to do this, but we don't have to, remember, because subtracting by a negative keep change, right? So it would be plussing that value. So delta G for the whole entire reaction would be a positive 465.1. Now just know that for this, your delta G values are in kilojoules. We multiply by mole value. And if you have mole in the denominator and a mole in the numerator, the moles cancel out. So we found out that the delta G for the whole entire reaction is 465.1 kilojoules. Is this spontaneous or non-spontaneous? Well, it's a positive value. Any delta G that's greater than 0 is non-spontaneous. So oh boy, am I spelling this right? I forgot the T. Spontaneous. It needs a little extra push from a source of external energy to get the ball rolling. And that's that. There you go, guys. Hope this helped. If you want to help us out, hit that subscribe button. Tell your friends, tell your classmates about this cool channel. Thank you so much, and I'll talk to you later. Bye-bye.